Hello everyone. In this video, we are going to see about the microbiological spoilage and control in condensed milk, dried milk and infant food. Infant food and milk products usually get contaminated due to the variations in processing, composition and storage conditions. Condensed milk with a high sugar content and low water activity is affected by osmophilic yeast and mold growth, and dried milk, on the other hand, are unaffected by spore formers and other microorganisms if moisture is reabsorbed due to the poor packaging or improper handling, while the infant foods are contaminated by post processing and storage conditions. Let us see about condensed milk. Unsweetened condensed milk acts as a favorable media for microbial growth. Improper handling can cause the surface growth of yeast and molds. Poorly sealed containers contains oxygen and it helps in the proliferation of organisms. Spoilage of condensed milk are caused by Bacillus species, Enterococci and Pseudomonas. What happens when the condensed milk is spoiled? Number 1. Gassy fermentation. There will be a gas formation in the product typically after 10 to few weeks of the usage, and the additional indicators increase the acidity, formation of lumps and darken the inner surface of the container. These are caused by the coliforms, Bacillus cereus and Clostridium botricum. Number 2 is bacterial thickening. There will be a gradual thickening in the product by the microbial activity or prolonged storage at the room temperature. This condition is marked by high bacterial load or increased acidity and causes the unpleasant cheesy smell and taste. This is due to the Staphylococcus aureus and Bacillus subtilis. The last one is mold button formation. Mold buttons appear as lumps of varying size with a color ranging from whitish yellow to reddish brown. They are found on the surface of the product or just beneath the surface of the product. This mold continues to grow until the oxygen in the surrounding air are fully depleted. These are caused by Aspergillus repens, Atlanticus glaucus and penicillin species. The spoilage of the condensed milk is prevented by thermal processing, water evaporation and sugar addition. In thermal processing, pasteurization process is done. The milk is heated at a high temperatures around 85 to 90 degrees Celsius for several minutes before the evaporation process and sugar addition steps. This heat treatment helps in destroying the most of the microorganism and inactivating the enzymes that leads to deterioration. By inactivating the microorganisms, the product remains safe and stable for long term without refrigeration. Next is water evaporation. During the production of condensed milk, approximately 60% of water content is removed through evaporation. This process is usually done under low pressure to prevent the overheating and nutrient loss. This removal of water significantly lowers the moisture level, which is a crucial factor for microbial growth. This concentration process also contributes to thick consistency and longer shelf life. The last step is sugar addition. Sugar is added to the condensed milk not just for sweetness but also as a natural preservative. The concentration of sugar added is 40 to 45%, which increases the osmotic pressure of the product. Due to this high osmotic environment, the moisture content becomes lower, which reduces the microbial growth. These were the microbial spoilage and prevention methods seen in condensed milk. Let us move to dried milk. In dried milk, commonly called as milk powder, the process involves the removal of water at lowest possible hygienic conditions while retaining all the desirable natural properties of milk like color, flavor, solubility, and nutritional value. During the manufacturing of milk powder, the water is removed by boiling the milk under reduced pressure at low temperature. The resulted concentrated milk is then sprayed like a fine mist into the hot air to remove the further moisture to produce fine powder. Usually, whole milk, that is, full cream milk, contains typically about 87% of water, and skim milk contains 91% of water. Approximately 13 kgs of whole milk powder or 9 kgs of skim milk powder can be made from 100 liters of whole milk. There are different types of milk powder in that skimmed milk powder contains less than 1.5% of fat and whole fat milk powder contains 26 to 40% of fat and buttermilk powder contains 4 to 8% of fat. In the process of dried milk, the pasteurization methods contain three steps. First step, low temperature longer time. In this, the milk is heated at 65 degrees Celsius for 30 minutes, which is also called as holding or batch method. The second step is high temperature and longer time. The heat treatment of 72 degrees Celsius for 15 seconds is applied, followed by rapid cooling to below 10 degrees Celsius. It is also called as continuous system or flash pasteurization. The last step involves ultra high temperature. The milk is heated at 149.5 degrees Celsius for 1 second or 93.4 degrees Celsius for 3 seconds. The processing involves the separation and standardization, preheating, evaporation, spray drying, and package and storage. The microbial spoilage of the dried milk can be found when there is a discoloration of odors, caking, or clumping in the milk powder. There will be a visible change in the discoloration in the normal color of the milk powder. It is usually caused by the growth of bacteria or fungi. Fungi like Aspergillus penicillium are grown on the surface and produce color patches like green or blue or black color. The discoloration is caused by thermophilic spore-forming bacteria, psychotrophic bacteria, lipolytic bacteria, proteolytic bacteria, molds, and pigment-producing bacteria. Off odors are one of the most noticeable signs in milk powder spoilage. It is caused by bacteria and fungi which produces volatile compounds like acids, sulfur compounds or amines during their metabolism. It is caused by coliform bacteria, streptococci, micrococci, actinomycetes, clostridia and bacillus species. The spoilage is also observed by caking or clumping in the milk powder. The milk powder gets hardened when it absorbs moisture from the air. As the moisture increases, the powder particles stick together and form hard lumps. These clumps not only reduce the quality and solubility of the powder but also creates areas where microbial growth can occur more easily, increasing the risk of the spoilage. It is caused by humidity tolerant bacteria and xerophilic fungi. This microbial spoilage can be prevented by controlling the moisture content of the milk. The milk is dried to a very low moisture level with water activity less than or equal to 0.2% to inhibit the microbial growth. Uniform drying is ensured to avoid the pockets of high moisture content. Monitor the moisture content regularly using a quality control test to maintain the consistency. The spoilage can also be controlled by hygiene, processing, and handling. The drying equipments, conveyors, storage bins, and packaging lines should be clean and sanitized before and after use. Proper airflow and filtered air supply should be maintained in the processing area to avoid the dust and spore contamination. The packaging of the product should also be safe and protective to avoid the spoilage. Use moisture proof, oxygen resistant, and light blocking package like laminated foil pouches and nitrogen flushed cans. The packages should be sealed immediately after drying to prevent the moisture uptake. Desiccants or oxygen absorbers should be incorporated in bulk packaging for added protection. So far, we have seen the microbial spoilage in the condensed milk and dried milk and the prevention methods that has to be followed to control the microbial growth in the product. Now, let us see about the infant foods. During the process of infant foods, there are several unique factors that can lead to the microbiological spoilage. Unlike normal food, the infant foods contain low acidic nature and rich in nutrient content, which creates a favorable condition for the harmful microbes to grow and causes spoilage in the food. Incomplete heating of the food causes uneven temperature distribution, which allows some areas of the food to remain uncooked that increases the microbial spoilage. There are some toxin producing microorganisms that cannot be destroyed by the heat, makes the food unsafe for the infants. The processing of infant food involves filtration process, emulsification, spray drying, cooling and storage, and finally the quality control. The microbial spoilage in infant food leads to nutritional deterioration. The spoilage in the infant food not only affects the safety but also leads to significant nutritional deterioration, making it unsuitable for infant consumption. The nutritional quality of the food degrades in several ways when there is a microbial contamination. The proteins are broken down by the bacteria or molds into ammonia and causes foul smelling compounds, reducing their availability and digestibility. The carbohydrates are fermented, especially by yeast and lactic acid bacteria, which leads to the loss of energy giving sugars and production of acids or gases. Fats undergo rancidity caused by lipolytic microorganisms, which results in unpleasant flavor and loss of essential fatty acids. These microbial spoilage results in health hazards in the infants. One major risk is foodborne infections that are caused by pathogens like Salmonella, Listeria monocytogenes, E. coli, and Chronobacter sakazaki. These microorganisms also cause severe gastrointestinal issues like diarrhea, vomiting, abdominal pain, and fever, which can lead to dehydration and electrolytic imbalance in infants. The prevention methods in the spoilage of infant food includes high pressure processing and freeze drying. High pressure processing is a non-thermal method commonly used for preserving fruits and vegetable based infant purees and food pouches. In this, the food product is sealed in a flexible packaging and subjected to extremely high pressure using cold water. This intense pressure is evenly distributed and inactivate the microorganisms and harmful pathogens without the use of heat. In freeze drying method, gentle dehydration is done to produce dry infant food like baby cereal mixtures, powdered weaning foods and fruit snacks. In this process, the food is frozen first and then it is placed under a vacuum. The frozen water content in the food directly converted into a vapor without passing through the liquid phase. It is also known as sublimation. In infant food, particularly in infant milk, there is a process held called microfiltration. In microfiltration, the proteins, vitamins, and enzymes are preserved which are heat sensitive. By avoiding high temperature, microfiltration helps in preserving delicate nutrients. It also reduces the microbial growth in the product, making it safer before it undergoes further drying or packaging. These are the microbial spoilage and prevention methods done in infant foods. From this, we can conclude that milk products and infant food are highly prone to microbial spoilage, which leads to compromise in their quality, reduced shelf life, and poses serious health risks, particularly in the infants. This spoilage is mainly driven by the bacteria, yeast, and molds which are introduced during handling, processing, or storage of the product. They can be prevented by undergoing the processes like pasteurization, hygienic processing, refrigeration, and proper packaging, which control the contamination. To ensure that these products remain safe and nutritious, routine microbial monitoring and strict compliance with food safety standards should be practiced. To the consumers concerned, not only these food products but packed and processed food products should be checked with the expiry date and proper packaging before consuming to ensure the safety of each individual. I hope the video is useful. If you like the video, like, share and subscribe.